Hi everyone, we are going to present our work accepted by ICCB 2023, Adaptive Rotated Convolution for Rotated Object Detection. In standard object detection, objects are assumed to be upright and aligned with image axis. Detection algorithms typically identify objects using horizontal bounding boxes. In contrast, rotated object detection deals with objects that can appear at arbitrary orientations within the image. This means that the bounding boxes can be rotated to match the orientation of the objects. To be specific, objects with similar visual appearance are placed with arbitrary orientations in these images. There are two challenges. First, multiple orientation of objects exist within the image, and second, the orientation directions of objects vary considerably across different images. The commonly used static convolution processes all the images with a fixed direction. Where it is reasonable for standard detection, it is not optimal for the rotated ones. To tackle this problem, we propose to rotate the kernel adaptively according to the orientation of objects. For images with different object orientations, we adaptively rotate the kernel according to different object angles. To deal with multiple orientation of objects, we introduce more kernels to capture the orientation information. These kernels rotate separately and then performing a convolution operation with the input image. Finally, they are weighted summed up to obtain the final output. Inspired by count-conv, this procedure is equivalent to summing the weighted rotated kernels first and then performing convolution with the combined weight. In this way, the heavy convolution operation occurs only once, achieving computational efficiency. Next, we provide more details of this method. First, to rotate the convolution kernel, we treat the kernel as a continuous space spanned by the parameters. We rotate the axis to get new sample points and sample new parameters from the kernel space to obtain the rotated convolution kernel. What is more, the rotated angle and the combination weight are predicted based on the input image in a data-dependent manner. Compared to standard convolution, which uses static parameters, our proposed adaptive rotated convolution generates the final parameters by rotating and combining the predefined parameters in a data-dependent manner to enhance the representation ability for rotated objects. Our methods effectively improve the performance of various rotated detectors. When combined with a highly competitive method, oriented RCNN, our approach achieves state-of-the-art performance on the DOTA dataset. Qualitative results also verify the effectiveness of our method. Thank you for your attention. For more details, please check the paper and the code.